Now we will see the second numerical. Design a lap joint to carry a load of 350 kilonewton. The rivets are 2 cm in diameter and placed in a double row. Given sigma T, that is a safe tensile stress, as 150 mega Newton per meter square. Safe shear stress is 100 mega Newton per meter square. Safe crushing stress or bearing stress is 246 mega Newton per meter square. Okay. Now we will write the given data. So the value of load is 350 kilonewton. The value of load is 350 kilonewton. The diameter of the rivet is 2 centimeter. That is equal to 0.02 meter. Okay, so we have the value of force and diameter. Then we have the value of stresses, that is sigma T is equal to 150 mega Newton per meter square. Tau is equal to 100 mega Newton per meter square, and sigma C is equal to 246 mega Newton per meter square. Okay, first of all we will find out the value of thickness of the plate. We will find out the value of thickness of the plate. We have the relation between diameter and thickness of the plate using, we have a formula, that is Unwin's formula. Unwin's formula. We have diameter is equal to 1.91 into root of T. Okay, in the question they haven't given the value of thickness. That's why I am using this formula to find out the value of thickness of the plate. Okay, so we have the value of diameter. Diameter is 2 centimeter. This formula is for in terms of centimeter. Okay, so D is equal to 2 centimeter into 1.91 into root T. Okay, from this I can get the value of thickness. So the thickness is found out to be 1.1 centimeter. Okay, we don't have the value of thickness. From this formula, just simplify, I will be getting the value of thickness, that is 1.1 centimeter will be equal to 0.11 meter. Now we got the value of thickness of the plate. Now we have to find out the number of rivets that is required in the design. To find out the number of rivet in the design, we need to find out the value of shear strength or the shear resistance and bearing resistance of the rivet. And we will compare these two values and we'll take the least value as the resistance of rivet to the shear and bearing. Okay, that is the shear value of one rivet in single shear. Okay, in the question they haven't mentioned this is a double shear, so I am taking a single shear. So the shear value will be pi by 4 into d square. This gives the area of the rivet into the safe shear stress. Okay, so this is a shear value, that be pi by 4 into the value of diameter is 2 centimeter, it will be 0.02 meter. The value of shear stress is 100 mega Newton, it will be 100 into 10 power 6. So I will be getting a value. So I will be getting a value of 31420 Newton. This is the shear value of a single rivet in single shear. Okay. Now we will find out the value of bearing resistance. Bearing or crushing value. Bearing or crushing value of one rivet. Okay, so the real formula is n into dt into sigma c. Here the value of n will be equal to 1 because we are finding out for the one single rivet. So the value of n is 1. Diameter is 0.02. The thickness of the plate is 0.11 meter. We found out in the previous step. Okay, and the value of sigma c is 246 mega Newton per meter square. That will be 246 into 10 power 6. So I will be getting the value of bearing resistance as 54,120 Newton. Okay, so from this two values I can write that the shear value is having less amount compared to the crushing value. Okay, so therefore the real strength of rivet is 31420 Newton. This is the strength of a single rivet. This is a requirement of this is a required strength of single rivet for the design. Okay, so we found out the requirement of a single rivet. We found out the strength of requirement of a single rivet for the rivet design. Okay, now we will find out the number of rivet that is required for our design. Okay, for that this is nothing. We have the total force, that is 350 kilonewton, divided by the strength of a single rivet. That gives the number of rivets. Okay. Therefore, the number of rivets required, that is n is equal to load divided by strength of single rivet or a one rivet. Okay, so I got the value. We have the load of, we are applying a 350 kilonewton load, and the value of strength of a single rivet is found out to be 31,420. So I will be getting the value as 11.1. Okay, so I will approximate as 12. Okay, so we require 12 rivets for the design. Okay, now we have to understand certain things. We have the rivet here. We have two plate, and this is our second plate, and it's the first rivet. We have a double rivet here. We have two rows of rivet here. Okay, we have totally 12 rivets here. So I will arrange the rivet in such a way that we will have two rows of rivet. Okay, there will be 6 rivet in each rows. Okay, and we are aware that the distance between each rivet, this is actually a double riveted joint. Okay, the distance between each rivet, that is nothing but the pitch of double riveted joint is found out to be 3 into diameter. Okay, and also this is the rivet. The pitch is found out to be 3D, and the distance from the edge of the rivet, distance of the edge of the plate, the distance from the edge of the plate to the nearest rivet hole is found out to be, the distance from the edge of the plate and the nearest rivet hole is found out to be 1.5 D. Okay, we got the value of pitch. Then we have something called back pitch. Back pitch is nothing but it is nothing but the distance of rivet in two rows. Okay, distance between rivet holes from the center of rivet from in the two consecutive rows. Okay, that's called back pitch. I repeat, it is nothing but the distance of center of rivet in two consecutive rows. Okay, and pitch is nothing but distance of rivet from a distance of the rivet from center to center in a single row. Okay, same row. It is for two consecutive row, and it is the range of back pitch is 2.5 to 3.5 times the diameter of the rivet. So I'll take the value of back pitch as 2.5 into diameter. Okay, these are the design constraints we want when you design a double riveted joint. Okay, so the value of pitch is, I will get the value of pitch as 3 into D, that is 3 into the diameter is 2 centimeter, will be 3 into 2, 6 centimeter, and the value of, that is the edge distance. Edge distance is 1.5 into D2, that will be 3 centimeter, and the back pitch is equal to 2.5 into 2, that is 2 is nothing but the diameter of the rivet, that will be 5 centimeter. Okay, now we'll design the rivet completely. That is, we found out the value of pitch, we found out the value of edge distance, and we found out the value of back pitch. Now we will arrange this, we will see the design in detail. Now we will see the design in detail. So I will draw the diagram. This is one. The single plate, this is the one. Okay, this is one plate here, and I kept one plate in this side. This is one plate, and this is the other end of the plate. We can't see because it's a top view of the plate. Okay, then in a single row we have 6 rivet. So I'll draw here 1, 2, 3, 4, 5, 6. Again here we have 2 rows, 1, 2, 3, 4, 5, 6. Okay, so diagram is not so neat. Sorry for that. And this distance, the distance between 2 rivet in a single row, that's called pitch. Pitch is found out to be 6 centimeter. Okay, and back pitch is nothing but distance of 2 rivet from in a 2 consecutive rows. Okay, this is one row, this is one column, and this is second row. Okay, this is back pitch, and back pitch is found to be 5 centimeter. Okay, this is back pitch. Okay, now edge distance is nothing but this distance, or I can say this distance, that is found out to be 3 centimeter. Okay, so this also will be 3 centimeter. Okay, so the total width or total breadth of the plate, that is small letter b, is equal to we have to find out this total distance. Okay, by that we will complete the design. Okay, what will be the value of B? You can see we have 6 rivet in a single row. This will be, and the pitch is found to be 6 centimeter. So we have pitch number 1, 2, 3, 4, 5. So we have total distance of 6 into 5. Okay, that is the number of, that should be the minimum distance to keep the rivets. Okay, plus we have to add this 2 edge distance, that will be 3 centimeter into 2 into 3 centimeter. Okay, so the total distance is 6 into 5, 30 plus 6 will be 36 centimeter or 0.36 meter. This is the value for the breadth of the plate. Okay, so we have, you can see here we have 5 distances, 1, 2, 3, 4, 5. Then we have edge distance of 2, one here and one on the other end. So that will be 6 into 5. 6 is nothing but the pitch distance. 5 is, we have 5 pitch distance plus 2 times of edge distance, 2, 1 here, 1 on the other side, and the edge distance is found out to be 3 centimeter. So we got the final value of breadth of the plate as 36 centimeter. Okay, so that's all about this lecture. Thank you for listening. Take care.